My name is Thomas Watson, and why am I talking to you today? Basically, I'm an open source developer, and you can find all my stuff at GitHub under /Watson. But also, I'm the Node.js lead at Opbeat, where we do a lot of performance monitoring of Node.js, front-end stuff, React, Angular, etc. And then I'm a member of the Node.js Diagnostics Working Group under the Node Foundation, where we are researching and developing the new diagnostics tools that are coming into future versions of Node. And by the way, I'm on Twitter as well. You can follow me there. I'll tweet out some links to my slides after the talk. So if there's anything in the slides you wanna read again, then you can check that link. And of course, if you have any questions that I don't answer during the talk or afterwards, feel free to give me a shout on Twitter at any time. I'll respond to everybody. So yeah. So my talk is called Instrumentation and Tracing in Node.js. And this is something that you do in a lot of programming languages, but why is this hard to do in Node? The problem with Node is also one of its strengths. Node.js is single-threaded, and that by itself is not really a problem because Node is really good at handling multiple requests at the same time. So normally when a request comes into a Node HTTP server, which is what we typically use Node for, we can start to look at what goes on during the trace. Let's say, during the request. So let's say that, you check something in the Redis cache, for example, to check if you have whatever the user is requesting, and then afterwards you may be checking something in the database, and you might even store some state in the database. So you get like this nice, if you want to graph it, you get this nice waterfall model of what goes on during a request. And we call these things normally, we call them traces. So we take measure the start time and end time, and we use that to determine what goes on and what is slowing down our app. And then we call like the overall thing, we call normally that a transaction. But of course, what can happen is that an error happens during one of these asynchronous events. And you get a stack trace, and it says, the error was right here in your code. Get line number, everything. But what you don't get is you have no clue what request actually down that waterfall caused that error to happen. And a lot of times, errors are related to data that you expect to be something, but it's something different. And it would be really nice if we could go back and actually figure out what was the original URL that was called for this function finally after a couple of async steps to be called. So let's look at the Node.js event loop and figure out why this is hard. I got exclusive pictures of it here. So if we graph what goes on in the Node process, we have an incoming HTTP request, and it does something, and then it sends a request off to the database, and then it waits for the database to return, and then it returns. There's another yellow blob there when it returns, and it does something else, and it waits. And in the meantime, there's just dead space. The Node process is not doing anything. This is all synchronous code. And then you get another HTTP request that comes in, and it also uses pieces of this space that is available to run the synchronous code. And let's say we want to figure out what is the current request like all the time. At any time, we want to figure out what is the current request that goes on every time some synchronous code is running. So what we could do is we could, every time a request comes in, we could have a global, and we could set it to, we could call it current request, and we could set it to whatever the current request is. The problem, of course, is that if we fast forward in time here and see now the second request comes in, we set the current request to request number 2, and that's fine when the second piece of synchronous code runs. But then when we get back to the second piece of the first request, it actually points to the second request because that's the last thing we ever set the current request to. So of course that's a problem. And what we want to do is we want to figure out a magic way to make sure that current request also always points to the right current request. and not just the latest one to come into our server. So the solution to this, can anybody see what this is? It's a monkey patch. Instant rim shot there. Okay. So what you can do is you can override all async stuff in Node. So let's say this is a timer, and we just want to make sure that every time the callback for the timer runs, we want to reset whatever the current request was to whatever current request was when the timer was queued on the event loop. So we just make a reference to the original timer set timeout function, then we override it with our own function to be able to inject our own code and do some logic every time a timer is created. And then we just make a note of, okay, what is the current request now that people are calling set timeout? And then we call the original set timeout, because of course we don't want to break anything. And we, instead of passing it the callback that the programmer gave us, we pass it our own callback so we can get notified when that timer finishes. And of course, we make sure to call the actual callback that the user actually wants to have called. And then just before we call that callback, we just reset the state of the current request to whatever it was when the callback was queued. And that is, like in all simpleness, that's actually what happens. And it's kind of like magic. So basically what we have to do is we have to basically patch everything. We have to patch the world. We have to patch timers. We have to patch promises, the new native promises that we have in Node. We also have to patch process next tick, and we have to patch everything that goes on inside libuv, because libuv is actually the part of Node where all I/O is happening. So every time you talk to the file system, every time you talk to a TCP socket, it goes through libuv. And just one bullet here, but libuv is huge. So that's where most of the stuff we need to patch is. And then we also need to patch certain third-party modules, because certain third-party modules might do their own I/O that is not directly controlled by Node, have their own callback queue and stuff like that. So there are some gotchas that we have to take care of. So this is basically how all performance monitoring tools you use today work. This is how Opbeat work, the company that I work for. This is how New Relic works. Seems kind of messy, right? It would be nice if Node provided a way for us to do this without having to patch everything. So enter AsyncHooks. AsyncHooks is a new API that the Node Foundation or the Diagnostics Working Group is working on. And AsyncHooks have been around for a long time, at least in theory. It hasn't been in your Node application, but it's been worked on for a long time. It used to be called Async Wrap. It was actually introduced by another name called Async Listener, I think it was called, originally back in 0.11, and then was there for 2 versions, and then it was removed again. So Trevor Norris is the guy who is doing all the hard work, who's working on it, and he just said here in, when is that, September, oh, Async Wrap is dead, we're now calling it AsyncHooks. So it's now called AsyncHooks, but it actually is already shipping with Node. It's been shipping with Node since version 4, but you just didn't know this. And the reason why you didn't know this is because it's nowhere in the documentation, because this is still a very experimental thing. But you can actually still access it if you want to play around with it. I probably wouldn't use it in production if I were you, but you can play around with it. And it's still, behind the scenes, it's still called Async Wrap. This is something that we are changing as time moves on. But it's still called Async Wrap. So the way that you access it is you use this function called process.binding, which is a way for you to access stuff in libuv, in the C layer of Node. And you can actually access the Async Wrap directly using process.binding. You get a JavaScript object back, a normal JavaScript object you can use. And then you just set up some hooks. And AsyncHooks needs a init hook, a pre-hook, a post hook, and a destroy hook. All of them are optional. And then you just enable it. And what does these hooks look like? It's basically just functions that you give it. And these functions are hooks that will be kind of like event emitters. They will be called whenever something happens that has something to do with asynchronous stuff. So like every time you queue a timer, or every time you want to make a TCP connection, stuff like that, read the file system, right when you initiate the call that could potentially do something asynchronous, the init hook will fire. And then just before the callback that you gave is called, you will the pre or before hook will fire, and then after the callback is finished calling in a synchronous manner, the post hook will be called, and then at some point when the async wrap object is garbage collected, is destroyed, you will see a call to the destroy hook. So let's test this. Let's try to get a file descriptor from the file system of the current file. So we require fs, we do fs open, and just before we log some data so we can see what it looks like. So this is the entire program. And we get, it says, user before, because it's not calling in any of the hooks yet, so we get the user before. Then we get async wrap init, because we are now queuing the callback by calling fs open. Then at some point after, when it actually has got the file descriptor, so right after that it prints out user after. But then at some point we get the pre-hook. That's when it's ready to call the callback. And so this all runs synchronously. You get the pre-hook, then the callback is actually called, so we get user : done is printed out. Then we get the post hook, and then at some point later we'll get the destroy hook. Not directly later, but at some point later when the object is garbage collected. So why am I using log and not just console log? The reason is, not many people know this, but console log is actually asynchronous. There's a lot of magic going on under the hood to make it appear synchronous, but in reality, console log is asynchronous. So what happens if you do something asynchronous inside of the init function? You'll get an infinite loop, because it will keep calling the init function all the time. So you'll get an error. In this case, we'll just say console log is not a function, because it doesn't make sense to call console log in there. So what we can do if we want to debug this, normally you won't use console log in here, but it's really nice for debugging purposes. So you could either do fs write sync to stand it out, and if you want to have nice formatting, you can use util format. It's kind of quirky. So there is this secret function that actually ships with Node that is called process._raw debug that is basically behaving like console log, but it's just synchronous. So we'll use that instead, and we get the functionality that we expect. There's a lot of stuff about what is actually given to you in the init function. I'm not going to go too much into this, also mainly because this has changed, or this is changing. So this is actually, if you use process.binding right now, this is the 4 arguments you'll get. But in the very near future, we're actually going to change this, and there's going to be a link later to where you can read up on the new API that's coming out. But you'll get an ID, which is like the ID of it's just an incrementing ID of the current context. You'll get a provider, which is basically just an ID referring to who is actually making this, queuing this callback. You can actually figure out what all these provider IDs mean by accessing the .providers constant on async wrap. Right now, these are still in this slide. It's IDs. This is also, if you want to play with this now, it's going to be IDs. But in the future, there's actually going to be a string. But then you can see, like, is it the TCP connection that is being made? Is it timer related or whatever? And in some cases, you will also have something will be queued because of something else. So you will have a parent UID, which in the new version of the API is going to call the trigger ID. And then you have handle objects. And handle objects is actually a reference to the messaging protocol that happens between the JavaScript code and the C code of Node. So Node is actually part JavaScript, part C++. And when Node talks to libuv, it uses these handle objects to pass data back and forth. So this is an example from NetConnect, where we actually create two handle objects. It's these two here, a TCP connect wrap and a TCP socket. And you can see we set the address and the port on the request, and we have some callbacks on the socket. And you can actually access these via the handle object. So you can figure out what is the port and the IP that we're trying to connect to, for example. So a little gotcha about timers. Timers are really, really optimized in Node.js, so they will actually share the same handle object. So the init function, the handle object will only be initialized once, and it will only be called. So the init callback will only be called once. So if you have two timers that are set to actually be executed, their callback is set to be executed at the same time, you'll actually see that their hooks will only fire once, even though you have two timers. And this is purely an optimization strategy employed by Node. So it's just a thing to know. So if you want to do something with timers, you need to probably make your own logic to handle that edge case. So just very quickly, a real-world example. And again, I'm going to tweet out a link to this later, so you can see this in more details. But let's try to keep this current request property in sync all the time. So we just make a reference of what is the ID of timers, because we want to handle that separately and we still basically want to do our monkey patching in this case. So we set up the async wrap callbacks, enable them. We have two state maps that we use to keep state of what was the current request before and after we queue a callback. And in the init function, we basically just set this init state to whatever the current request is. And in the before state, we just restore it to it was when the init state was set. And in the after state, we just take it back to what it was just before the before state. And then we just clean up after ourselves in the destroy. Finally, AsyncHooks Gotchas. The handle creation time is not always obvious. For example, if you make a HTTP server, the init function will not be called until you actually bind to a port. So that's not until you actually call listen. So it's sometimes not really obvious when the init callback is going to be called. Console log, you can't do that. You have to use raw underscore raw debug. Process next tick is currently not covered by this. It will be in the future, very soon. Timers, as I said, you need to take care of that if you want to have the init callback being called for every callback that is queued. Promises is still not covered because V8 doesn't actually give us access to promises yet, but it's something we are working with Google to fix. So hopefully very soon we will have these hooks being called for promises as well. And it's still not possible to have multiple hooks, so set up multiple async hooks at the same time. You can read all about the new API here on this in this pull request. So there's a few differences with what I showed here, what you can use now as opposed to what's actually shipping. There's going to be a solution to the I/O and user land. So there's going to be a new Embedder API. It's not shipped yet, but it's coming. That allows you to, if you're doing your own I/O, if you're doing native modules, you can actually fire these events yourself. So in JavaScript, it will look like this. You can emit an init call. You can emit the before, and so you can actually make Node emit these events if you're doing your own low-level stuff. ES modules is still up in the air, how that will work, but we're working with TC39 to make that, to solve that problem as well. It's hopefully being resolved. And yeah, this is the API proposal that I was talking about with the new API. You can visit the Diagnostics Working Group on GitHub. There's a link there. And read the documentation, of course. And there's a tracking issue where you can follow along what the progress of how close you are to shipping this. And that's it. And I think I'm out of time. Thank you.